Hello! In this module, we're going to be adding some sparkly lights to our cardboard robots. And we're going to be doing that. We're going to do that by adding some NeoPixels. NeoPixels are great. They're these little individually addressable, colorful LEDs. They're really fun, and they also have a lot of great libraries that support them because they've been around for a while. So, to do this module, you will need a couple of things. You will need a completed quick start. So if you haven't done the quick start yet, go back and do that module first, and then come back to this one. You also need some NeoPixels. And there are a couple of different form factors that I have when I do workshops. I have little rings, and I have tiny little strips that I prepared. They behave essentially the same, and you can chain them. Basically, anything you do with NeoPixels is a strip in software, whether it's a grid or a ring or whatever. So great. Oh, I'm going to be using the ring for the rest of this module going forward, but it behaves the same way as the strip. This project has a little bit more dependency stuff, so we're going to spend a little bit more time setting up dependencies. So let's get going with that. We need to install a special version of firmata that is NeoPixel aware so that it can push the NeoPixels in a performant way. So you can have long strips. I've had as long as like 400 or 500 pixels on this version using the special firmata, and it works pretty well. So if you'd like to go ahead and get started, you can just do a web search for Johnny 5 NeoPixel. And the top result, at least today, is Andrew Fisher's awesome NeoPixel library. That's what we're going to be using. And if you scroll on down, there's installation advice. And one thing you'll notice is that it requires you to install nodebots-interchange, which is another project of Andrew's, that helps you install custom firmatas. So we're going to go ahead and do this. And we're going to do that installation. And I've go ahead and install interchange. I'm installing with just G, so it's globally available, and it installs the convenient command line program. So I can run interchange. And it can do things like list different firmatas it supports. There's the NodePixel one we want. And it can also look for all the connected devices. So interchange ports. So let's go ahead and plug in our board. And we'll see it suddenly appears on ports. There's the port for our board. And here's the installation instruction. We're going to need to add one thing to that because we're using an Arduino clone. So go ahead and run the interchange program. We're going to tell it to install. Oops, I pasted the whole thing in. We're going to tell it to install this NodePixel firmata. We're going to need the image from the Uno because we're using an Atmega 320. We're using an Uno clone, but we're going to need to explicitly specify the port. So go back above, add the -p argument, and go grab the USB interface from above, which is called Adafruit, because that's the board we're using. And it will go ahead and it will install the special NeoPixel firmata to your Adafruit Metro. Great, so that flash is complete. Now we have a special firmata. All of your old firmata stuff will keep on working unless you're using a different custom firmata, like for lots of servos or something. But everything in all the modules I show will continue to function just fine with this one. So with that stuff done, we need to install the NodePixel library into our local project. So go back up here, npm install NodePixel. You might want to add save, so it adds it to your package.json file. Then we can bring up our source code. This is a copy of the quick start source code, and we can add NeoPixel stuff to it. So if we scroll on down a little further, we'll find a whole bunch of documentation. But we'll also find some code that we can copy and paste, because copying and pasting code makes everything a lot easier. So we're going to add the NodePixel library. We're going to require it, rather. Then we're going to make a strip. I'll just make it in here where we make our other things. After the board is ready, we will configure our strip. It has lots of different configuration parameters. The important ones here are that we're using the firmata controller because there's multiple ways to interact with these pixels. And we have a pin and a length. So I'm using a ring which actually has 16 pixels on it. So I'll change the length to 16. And a pin. which we'll be using when we build out the circuit in a moment. There's also gamma correction. I find for the rings, for the strips, 2.8, which is specified here, works pretty well. I find a lower gamma correction, like 1.5 or so, seems to work best for the rings, because every batch of these pixels is a little bit different. So with the strip defined, you can do some simple things. We can wait for it to be ready, but we can just do something simple like make it display something when we hit the button. So if we scroll on further down, we can see further details on how the API works. But the basic thing is, like, if you just wanted to change the entire strip at once, you can do like .color. In this case, it'll make it red. So when the button goes down, we'll make it red, and when the button goes up, we'll make it green. So a very hello world thing. You can also individually address it and do things sliding back and forth and all sorts of cool stuff like that, but we're not going to do that in this module. So with our software done, we need to actually wire this up to the circuit. So let's go scroll on back up, and I think there was a picture here that we can copy. If not, we're just going to go a basic simple strip from Johnny 5. So as you can see here, we have a data pin, and a ground and a voltage pin. We actually have 4 wires in our ring. The pins are all labeled on the back of the ring. The difference here is that in addition to data in, we have a data out. So if we wanted to chain a bunch of them together, we would use the data out pin. We'll ignore it for now. So we have a data out pin. So let's unplug our Arduino and wire it up. So our data in pin, which is input right up here, this black wire, we're just going to plug it into pin 6 because it's not taken. Otherwise, it could remap to a different pin. We have our power, which is going to go to 5 volts. And as long as you don't have too many of these, you can just power it off of the Arduino. If you have more than like 30 or 40 pixels, you probably want an external power supply, like some batteries or USB power supply. And let's plug in ground. And with that all wired up, let's go ahead and give this program a spin. So we'll save it. Then run our program. So try and hold it flat. So looking for a board. It's not plugged in right now. We'll plug it in. It has not found it. There's also no LEDs here. So let's try canceling that. Let's unplug that. So this all looks fine. Oh, it's wired up backwards. That's the mistake I made. Because orange means ground, of course. So hopefully that did not kill these NeoPixels. They can be a little fussy about that sometimes. Hopefully the fuse on the Arduino took care of that for us. So let's go ahead and run the program. It sees the board. Now when we hit the board button down, it turns red. And we lift up, it turns green. So this is like the simplest case where we're just changing the entire strip at once. You can actually individually address these and do all sorts of cool artwork with them. You know, you could show battle damage or something like that. A health meter, something cool like that. A rage gauge. Lots of things you could do with this. But our NeoPixels are working, and that is all for this module. So go ahead, have some happy hacking, and maybe pick up a different module. Give it a spin.